And I want to start with this warm-up. So let's start with the first question. There are 3 teams in the women's gymnastics finals: Russia, China, and the U.S. How many different ways can the gold, silver, and bronze medals be awarded? And we want to list all the possibilities. So I want you to take a minute and try this on your own. You can pause the video now. All right, so let's go through this together and make sure that we are doing this correctly. So we have 3 different teams. So let's just list out all the possibilities. We have, so getting the gold is different from getting the silver and the bronze. So it could be that the U.S. gets the gold, right? So the U.S. gets the gold. Let's say Russia gets the silver. So let's call this gold, silver, bronze. Okay? U.S. gets the gold, Russia gets the silver, China gets the bronze. Or U.S. gets the gold, China gets the silver, and Russia gets the bronze. Now, those are the 2 scenarios that I'm hoping to see. But it could also be that Russia gets the gold, the U.S. gets the silver, and China gets the bronze. Or that Russia gets the gold, China gets the silver, and the U.S. gets the bronze. We could also have that China gets the gold, the U.S. gets the silver, and Russia gets the bronze. Or China could get the gold, Russia could get the silver, and the U.S. could get the bronze. Okay, so that's 1, 2, 3, 4, 5, 6 different possibilities. And if you think about it, it makes sense. It looks like each team could be in each position twice. So that's 3 times the 2. There's twice that every team shows up in each position, which there's 3 of, so there's six different possibilities. All right, let's look at the next example. The ice cream stand at the state fair has 3 toppings: sprinkles, fudge, and Oreos. You are ordering a 3-topping sundae. How many different sundaes can you get? List all the possibilities. So you can pause it again to do this problem. Why don't you do that now? All right, so hopefully you came to the conclusion that there's only one sundae that I can get from this fair. Because if the person at the stand, the ice cream stand, puts sprinkles, fudge, and Oreos, and they do it in an order that's not sprinkles, fudge, then Oreos, what if they did fudge, then sprinkles, then Oreos, or Oreos, then sprinkles, then fudge? You're not going to know the difference. It's all on top of an ice cream. And you're not going to send it back and say, oh, I asked for sprinkles, fudge, and Oreos, and you gave me Oreos, fudge, and sprinkles. You would sound like a crazy person. So there's only one sundae. And that possibility is to have all 3 toppings. So what is the difference between these 2 problems? Why does one give us 6 results? They seem very similar. And the other one only give us 1. Well, I think we just touched upon it with the sundae here. The order matters for one. But not the other. All right. So there's the warm-up. Now, what we're going to do is we're actually going to split this up into 2 days. Today we're going to talk about when the order does matter, and these are called permutations. And then on Thursday we'll talk about, or the next day we'll talk about when the order does not matter. So this is advanced counting principles. And again, today we're talking about permutations. A permutation is an ordered arrangement of n objects: people, numbers, letters, etc. Okay, so the first warm-up problem was an example of a permutation, whereas the second one was not a permutation because there is no order that matters. All right. So make sure you fill out your guided notes while you're looking at this. So let's do our first example. There are 8 people running a race. How many different outcomes for the race are there? Okay, well, let's think about it. There are different positions that you can win the race in. So you can come in first, you can come in second, you can come in third, all the way up till 8th if there's only 8 people in the race. So if we think about how many people could come in first place, there are 8 people that could potentially come in first place. But then once somebody comes in first, there are only 7 people left in the race. So there are only 7 people that could come in second place. And once somebody comes in second place, there are only 6 people that can come in third place. And then there's only 5 people that could come in fourth place, and so on and so forth. 4 people that could come in fifth place, and 3 people that could come in sixth place, and 2 people that could come in seventh place. And then once all those people have crossed the finish line, there's only 1 person left to come in 8th place. So there's this many different outcomes for the race. Now that is a large number. And this number has a meaning, okay? This comes up so often when we multiply a number by all the numbers that are smaller than it. This comes up a lot, so often that there's actually a notation for it. I can write this as 8 factorial. It's called a factorial. And my calculator actually has a factorial button. And so if you go to math and then the probability section, you have to arrow over to the 3rd column. Number 4 is a exclamation point, and that is a factorial. And if I do 8 factorial, I get 40,320. Now if I actually just did 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, I would also get 40,320. That's a lot of different ways that this race could happen. Way more than you probably would have thought. Way more than I thought. Okay? But that's the number of different outcomes that could happen in this race. So let's talk about this factorial notation. So this factorial notation is saying 8 factorial means 8 times 7 times 6 times, typo, 5 times 4 times 3 times 2 times 1. And 5 factorial means 5 times 4 times 3 times 2 times 1. And 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? And since there's only one way to arrange 0 objects, 0 factorial is equal to 1. So we want to know, what is 6 factorial? Well, we can just do it in the calculator, or we can do this math problem out. I'm just going to go to my calculator and hit 6 math probability 4, and that gives me 720. So that's the factorial notation, and it's going to come up a lot because of the way that we're doing this. So let's go back to this problem where there are 8 people competing in a race, and we want to know how many different ways can the first, second, and third place medals be awarded. So once we have first, second, and third place, we don't care about the rest of the people. So again, there are 8 people that can come in first place. And then once that person crosses the finish line, there's only 7 people left in the race. So there's 7 people left to cross the finish line second. And then once this person who crossed the finish line second comes across the finish line, there's only 6 people left for third place. So this is not as many as the previous example, but we only care about first, second, and third place. And so if I do 8 times 7 times 6, that's actually only 336 ways that we can award a first, second, and third place medal. And this is actually what a permutation is. It's how many different ways can I order a certain number of objects out of a group of objects. So in this case, the group of objects are racers, and I wanted to take 3 racers out of the group and arrange them in a specific order. And we want to know how many different ways can we do that. The answer is 336. Now you can see we sort of have that pattern that we had before, where we had that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, but we wanted to get rid of, we didn't want the 4 times 5 times 4 times 3 times 2 times 1. Well, how many objects were there here? There were 8 people, and I was choosing 3 of them. So if we take 8 minus 3, and we take the factorial of that, that gives me 5 times 4 times 3 times 2 times 1, which cancels with that. And so we end up with our 8 times 7 times 6.